All right, so today we're going to be talking about the sum and difference formulas. So I want you guys to make sure before you watch this video that you've already done this assignment where you're taking that identity sheet that we used before and filling in identities 24 through 46. And so if this is in Classroom, it tells you exactly what pages to look at to do that. So you're going to want to do that first, and then double check on your sum and difference formula. So this should be starting with number 24, that you filled these in correctly, because I have students every year that mess this up. So the one that has cosine of u plus v, in between cosine of u, cosine of v, and sine, it is a minus. And then the one that has subtraction in between has a plus on the other side. So be careful on that. Lots of people mess that up. So just double check yourself. Okay, so I'm going to move this over. All right, so for these sum and difference formulas, we use those when we have the sine, cosine, tangent of the sum of two angles or the difference of two angles. So on example 1a, we want to find the sine. We want to find the sine of 7 pi over 12. Now, when you have 12 in the denominator, it's not one of those special angles that you can do the hand trick with. So what we're going to do is use two special angles that add to give you 7 pi over 12, which are going to be pi over 3 plus pi over 4. Because to add those, you find a common denominator. And then when you add, I promise, when you add pi over 3 and pi over 4, you get 7 pi over 12. So we're actually going to use this one right here, which is going to be number 24. And u is going to be pi over 3. And v is going to be pi over 4. All right. So I would start off over here and rewrite it as the sine of pi over 3 plus pi over 4. All right. Then I would use my formula. All right, so I'm going to move around a little bit. So starting off in the formula is the sine of u times the cosine of v. So u in this case is pi over 3, and v is pi over 4. So it's going to be sine of pi over 3 cosine of pi over 4. All right. Then to that, we're going to add, the cosine of u, sine of v. So cosine of pi over 3, sine of pi over 4. All right, and then we're not going to need that formula anymore, so I'm just going to move it out of the way real quick. All right, now sine of pi over 3, we can use our hand trick to find. And then same thing for cosine of pi over 4, and then the cosine of pi over 3 and the sine of pi over 4. So we use our pi over 3 finger, and when we do the sine, we're going to do the square root of the bottom fingers over 2. So pi over 3 has 3 bottom fingers over 2. Right? And then for cosine of pi over 4, we use our pi over 4 finger. Cosine is the square root of the top fingers over 2. Right, and we'll do cosine of pi over 3. So use our pi over 3 finger, square root of top fingers over 2. And then for sine of pi over 4, use the pi over 4 finger, square root of bottom fingers over 2. All right. So now this just leaves us with some fractions that we need to multiply and then add together. So when we multiply fractions, you multiply across the numerator and across the denominator. So we have to know how to multiply fractions, and we need to know how to multiply radicals. So when we multiply the square root of 3 times the square root of 2 is the square root of 6. And then 2 times 2 is 4. All right, then we have plus. And same thing over here, multiply across the numerator and across the denominator. Right, and then I would want you guys to write that as one answer. If there is a common denominator, so you just put it in the denominator, and the numerator is the square root of 6 plus the square root of 2. That is what the sine of 7 pi over 12 equals exactly. Okay, so we are going to do the next one. This time we're going to find the cosine of 13 pi over 12. Now again, when there's a 12 in the denominator, it's not a special angle. We can't do the hand trick, but there are two special angles that subtract to give you 13 pi over 12. Okay, so let me grab this guy and move it up for a second. Okay, so we're going to do the cosine, and then we are going to do the cosine of two angles subtracted. So U is going to be 5 pi over 4, and V is going to be pi over 6. All right, and the cosine of two angles subtracted is this one right here. So it's going to be the cosine. I'm going to go ahead and rewrite 13 pi over 12 as 5 pi over 4 minus pi over 6. All right. Then, whoa, the parenthesis moved. All right, then we're going to use that identity. In for U, I'm going to fill in my 5 pi over 4. And in for V, I'm going to fill in my pi over 6. All right, and then it's going to be plus, and then the sign of both of those. So fill in 5 pi over 4 for U, and pi over 6 for V. All right, now I don't need this guy anymore. So I'm going to move him out of the way. Okay. Now what we'll do is use the hand trick and figure out what all of these are equal to. Now we do need to know what quadrant 5 pi over 4 is in. So 5 pi over 4 is in quadrant 3. So cosine is negative in quadrant 3, and so is sine. So I would go ahead and make those two parentheses negative on the inside. And then I don't have to worry about that anymore. So when I do the cosine of 5 pi over 4, I use my pi over 4 finger, and it's the square root of the top fingers over 2. All right, when I do cosine of pi over 6, I use my pi over 6 fingers, square root of top finger over 2. All right, and then for sine of 5 pi over 4, I've already written that it's negative because it's in quadrant 3. And then it's going to be the pi over 4 finger and the square root of the bottom fingers over 2. And then same thing for sine of pi over 6. Use the pi over 6 finger, square root of the bottom fingers over 2. All right, and then from here, we are just multiplying these fractions, and then we're going to add them. So we will multiply across the numerator and across the denominator. Multiply across the numerator and across the denominator. We do have a common denominator, which is nice. So that's going to be negative square root of 6 minus square root of 2 over 4. And that's all we can do. We cannot subtract those. I should have mentioned that on the last one. You're going to only add and subtract like radicals. So if we had square root of 2 plus another square root of 2, we could add them. But these are not like radicals, so we're done. Okay, and now the next one, we're going to do a tangent. All right, we're going to find the tangent of 5 pi over 12, and we're going to use the fact that when you add pi over 4 and pi over 6, you get 5 pi over 12. So U is going to be pi over 4, And V is going to be pi over 6. And let me move this guy over. All right, so I would rewrite tangent of 5 pi over 12 as the tangent of pi over 4 plus pi over 6. All right, and then I would use this formula here. So we're going to have a fraction. The numerator is tangent of u, which in this case, u is pi over 4, plus tangent of v, which in this case is pi over 6. And then over 1 minus those two multiplied by each other. Okay, move that boy down. All right, so now we can use our hand trick and figure out what these tangents are. So for the tangent of pi over 4, we use our pi over 4 finger. And we're going to do the square root of the bottom over the square root of the top, which is the square root of 2, over the square root of 2, which is just 1. All right. And then for pi over 6, we're going to use the pi over 6 finger. We're going to do the square root of the bottom over the square root of top, which would be 1 over the square root of 3, or the square root of 3 over 3. All right, and then in the denominator, same thing. We already found that the tangent of pi over 4 is 1, and the tangent of pi over 6 is the square root of 3 over 3. Now, one thing that makes these tangents a little more difficult is we can't leave a fraction inside of a fraction. All right. And so what we're going to do, see, because both of these fractions have this little denominator of 3, so what I can do is just multiply the numerator and denominator by that 3. Okay, so I would distribute that on the numerator. I'm going to get 3 minus, and then when I multiply the 3 by this whole thing, the 3's cancel out. I'm left with the square root of 3. All right, same thing on the denominator. We're going to distribute that 3. Oh, this top one should have been a plus, sorry. I just didn't bring down the plus. Okay, now I have a different problem, a different issue. My new issue is that you cannot leave a radical in the denominator. Okay. And then to do this, it's been a while since we've done this. What we do is we multiply by the conjugate of the denominator. So our denominator is 3 minus the square root of 3. So we're going to multiply by 3 plus the square root of 3. Right. So in our numerator, we're going to need to distribute the 3 and then distribute the square root of 3. Now, when we multiply square root of 3 times the square root of 3, it's the square root of 9, or just 3. And then in the denominator, we can do a shortcut multiplication and just do 3 times 3 and negative square root of 3 times the square root of 3, which would be minus 3. I'm running out of room. All right, this is a lot, I know, but now we're almost done. So we're going to add the 9 and the 3 together, and that's going to give us 12. And then we'll add 3 square root of 3 and another square root of 3 square root of 3, that's going to be 6 square root of 3. And then in the denominator, that's going to be 6. Right, and then as long as all 3 of the numbers that are outside of the radical can be reduced by the same thing, we need to do that. So we would reduce through by 6. Ooh, and that's our answer. That is the exact value of the tangent of 5 pi over 12. Now, in the past, on the challenge exam, they try to trick you into using the formula when you don't have to use the formula. All right, so you're going to need to use the formula if you're given the sign of the difference of 2 angles when these are special. So if they're both special, use the formula. So special angles have a denominator of 2, 3, 4, and 6. So those are special. You would want to use the formula. So whenever we were finding our U and our V, they were always special angles. Now, when you look at this other one, when that denominator is 12, it's not special. So it's the sign of 2 angles that are not special. So when that happens, that's when you're going to go ahead and add or subtract. And then use the hand trick. Okay, so if I subtracted 5 pi over 12 minus pi over 12, that's going to give you, I'm going to write that somewhere else because I don't have room. That's going to give you 4 pi over 12, or the sign of pi over 4. And then you can just use the hand trick to do that. I mean, so goodness, sorry, that's the sign of pi over 3. Geek. Then you can use the hand trick to find that. Use the pi over 3 finger, and then it's the square root of the bottom over 2. Okay, so watch out for that. They like to trick you into trying to use a formula and wasting your time. So let's look at example 2 real quick. So if you were given this to find the tangent of 7 pi over 16 plus 5 pi over 16, you might start using the formula, but if you notice, these are not special. The 16 in the denominator is not special. So we're going to go ahead and add. When I add those, I'm going to get 12 pi over 16, and that is going to reduce to 3 pi over 4. All right. And it's special because the denominator is 4. Oops, sorry. So we're going to hopefully know that that is in quadrant 2. And tangent is negative in quadrant 2. And then we'll use our pi over 4 finger. It's the square root of the bottom fingers over the square root of the top. And that's going to be square root of 2 over square root of 2, or just negative 1. Okay, these last examples are actually the easiest ones that we're doing today, which is usually the opposite of what we do. Normally we start with the more difficult, or we start with the easy and end with the more difficult. I think these ones are easier to do. All right, so our directions on these are to write the expression as the sine, cosine, or tangent of an angle. So what's happened on these is we've already used the formula. So what we'll do is look on the right side of our sheet of our formulas and see which one it looks like. All right. So on A, I have sine cosine minus cosine sine. So sine cosine minus cosine sine to me looks like that one. All right. And then I can tell that U is going to be 3 and V is going to be 1.2. All right, so I'm going to work backwards. So that means that this is really the sine of 3 minus 1.2 or the sine of 1.8. And we don't know what that is. There's no way for us to figure out. And it just tells us to write it as an expression, so we're done. Okay. So let's look at this next one. This next one is obviously a tangent. So when I look at it, it's tangent minus tangent in the numerator, and tangent minus tangent in the numerator is this one. So that means my U is going to be 45, and my V is going to be 30 degrees. So this is the tangent. Okay, so this one is minus. So the tangent of 45 degrees minus 30 degrees is just the tangent of 15 degrees. And that's all we have to do. Okay, one more. We're going to take it one step further. So we're still going to match it up with what's on the right side of the equal sign, but then we should be able to, in the end, give an answer. All right, so we have cosine, cosine minus sine, sine. So cosine, cosine minus sine, sine is this one, where U is going to be pi over 16 and V is going to be 3 pi over 16. So this is really the cosine of those two angles added to each other. All right, so it's going to be the cosine of 4 pi over 16 or the cosine of pi over 4. All right, and then we will just use our pi over 4 finger. It is in quadrant 1, and then it's the square root of the top fingers over 2. That's it. All right, so your assignment is to do these. Now, pay attention. Don't forget what we talked about in this little box right here. Don't get tricked by these problems. So if you're told to find the sign of 2 added or 2 subtracted from each other, if they're special, use the formula. If they're not special, go ahead and add it and then use the hand trick.